Start one sample t-test. First, we'll talk about when to use t-test. Then we will introduce t-distributions. Finally, we'll talk about how to conduct one sample t-test. Here is an example. According to Journal of College Health, nationwide, the average amount of alcohol college students consume is 5 drinks per week. President of Hofstra University will start the policy of non-tolerance if Hofstra students' drinking is above national average. Your study with 50 students returned survey indicated that the average alcohol consumption at Hofstra is 5.8, with a standard deviation of 4. Should the president of Hofstra University start the policy of no tolerance? That is the mean alcohol consumption in Hofstra significantly higher than the national mean? Here it indicates the population of all college students. From the question we know the meal is 5 drinks per week. From the question we don't know the standard deviation of the population. This is more common in the real life. For example, sometimes we know the population mean, but we don't know the population standard deviation. Suppose we take a sample of 50 students from this population, then we compute the sample mean. We plot the sample mean here, it will be around 5 drinks per week. If we take another sample of 50 students, we can compute another sample mean. If we do this over and over based on a limited number of samples, we will have a lot of sample means. When we plot these means, we will have the distribution of sample means. The x-axis indicates all means. The y-axis indicates the probability of having a particular sample mean. The mean of the sampling distribution is the population mean, which is 5. The standard error of this blue distribution, we don't know, because when we know the population standard deviation, we can compute the standard error. Now we don't know the population standard deviation, so this one is in question mark. Now we take a sample from Hofstra University and compute the mean based on our sample. The mean is 5.8, and based on these 50 Hofstra students, the standard deviation of our sample is 4. Because we don't know the population standard deviation, we use our sample mean of 4 to estimate the population standard deviation. Then we can estimate the standard error of this distribution of sample means. So the estimated standard error as x bar equals to as the sample standard deviation divided by square root of sample size. So it is 4 over square root of 50, which is 0.57. Remember that this standard error is estimated by our sample based on 50 Hofstra students. Therefore, if we do not know the standard deviation of the population, we use our sample to estimate the population. Therefore, here we do not have just one distribution. We have a set of distributions. These are called t-distributions. The mean of this distribution is 5, and the standard error estimated by our sample is 0.57. then the degree of freedom of this distribution is sample size minus 1, which is 49. When we have other samples, for example, we have another sample with 6 people, then the degree of freedom is n minus 1 is 5. The estimated distribution is wider or flatter. In other words, the standard error is bigger. When our sample size is greater than 100, then the estimated distribution or the estimated curve is closer to a normal distribution. So for this example, therefore for t-distributions, we have a set of distributions corresponding to different degree of freedom. When the degree of freedom is small, such as the blue one, n equals to 6, the t-distribution is flatter, meaning that it has a bigger standard error. When the degree of freedom is bigger, such as this orange distribution, the t-distribution is narrower. When the sample size is greater than 100, then the t-distribution is very close to a normal distribution. The mean of the t-distributions is the population mean, and the standard error equals to the standard deviation of the sample divided by square root of sample size. Now let's look at our previous question. Is the mean alcohol consumption at Tufts University significantly higher than the national mean? Here is the t-distribution. The degree of freedom is 49. The mean is 5, and the estimated standard error is 0.57. First, we state our hypothesis. The research hypothesis is mu Hofstra is greater than 5. The null hypothesis is mu Hofstra is less or equal to 5. Second, we state the decision criteria. It is a one-tailed test. We look at the right tail. Alpha is 0.05, so P in the right area less than 0.05. Degree of freedom is 49. It tells us which t-distribution we are using. Then we need to look at the t-critical score instead of z-critical score. T-critical score is 1.684. We use t-table to find out the t-critical score. Here is the t-distribution table. As you can see, the left column presents the degree of freedom. Each row, according to each degree of freedom, presents a t-distribution. On this page, it listed the degree of freedom from 1 to 16. It actually presents 16 curves. Then our degree of freedom is 49, so it resumes to the next page. This page presents the degree of freedom from 17 to 60, then 120. After 120, beyond 120 is actually the normal distribution curve, so everything just clusters into the last row. Then we need to identify our curve of 49. If you look at the degree of freedom, it only runs from 40 then 60. You should look at 40 because that's the closest to 49. Then that row is the curve you should have. Then you have the alpha of 0.05, and it's one-tailed test. Therefore, on the top of the table, you see the proportion in one tail and the proportion in two tails. Therefore, you should look at alpha under the proportion of one tail, which is 0.05. Therefore, the t-critical score is 1.684. Here we have the t-critical score. It is positive 1.684. Then the third step is to compute the estimated standard error. It equals to the standard deviation of the sample, which is 4, divided by sample size, which is 50. So it is 0.57. The first step is to compute the t-observed score. It is very similar to the z-observed score. You just replace it with the estimated standard error. So it is 5.8, the sample mean, minus 5, the population mean, divided by estimated standard error 0.57. So the t-observation is 1.40. The last step, you compare the t-critical score to the t-observed score. Because t-observed score is less than t-critical score, your sample does not fall in the critical region. Therefore, we fail to reject the null hypothesis of H0 is mu less and or equal to 5. Therefore, the conclusion is that the half-street student was not significantly different from the national norm on the average alcohol consumption per week. Here is using 5 steps to compute the t-test. Now you can take out the in class 1 and finish the 1 sample t-test on your own.